questions, save them for the end because we kind of got to breeze through a lot of this stuff. Aside from that, let's go to the next slide. And really quick, I'll mention we're going to have a 15-minute intermission. And on Sunday, make sure to come to game night. And also, there's a giveaway we're doing right now. So make sure you go tag 2 people, get some free money, 3 gift cards, $50. That's a nice little pocket change right there. So, all right, we on? Okay, go back to the sign page. All right, if you haven't already, make sure to sign in with this QR code. I'm going to give you a couple minutes to do it right now. Just make sure it's tracked on your experience record.
Yeah. This is also mostly, I know you guys probably already signed in at the front if you're in person, but if you're online on Twitch, make sure to sign in. This is for you guys.
All right, so I'm following the Twitch stream right now on this thing. So what we have on the menu for you today are basically 6 different topic buckets that are very closely related to your assignments, all right? So the first one is problem solving and formatted output. The next one is functions and libraries, followed by if statements and decisions. Next we go into loops, and then lists and strings, and then finally we'll end with a little bit on files and to-do lists. Here's some helpful resources if you want to follow along in live code. Rapidly is really good. Next slide. All right, now on to the first section. Formatted output is essential. We're going to be talking about next slide. Here's a quick cheat sheet for formatted output if you guys need to follow along with that. Okay, let's go into a quick refresher on formatted output and different data types in Python. So by now, I'll be absolutely sad for you if you don't know the basic data structures or the basic elemental structure in Python, all right? We got strings, ints, integers, floats, and the last one we don't have right there, which is arrays. These are like the 4 most important types of little built-in data structures that almost every language shares, right? So for example, we have a name, Robert. It's enclosed in quotations, so you know it's a string. Then we have a float, which is basically any decimal point number. So we have 11.99, and then we go and we see an integer, so it's a whole number, right? Okay, so I already asked you guys this, but most people still don't remember how to use literals, but they can be really useful because it's really easy to use. I personally forgot about it for the entire first year. But the way you use it is it's very simple. So just like the format function, it allows you to insert variable values into the string. So the way you use it is you put an F in front of the first opening quotation, quote, and then inside of it, you put curly braces with the variable name that you're trying to insert at that spot. And furthermore, if you do want to format output, then you add some format specifiers next to the code. So if you look at the example right here, this will output if you don't put the variable names into the parentheses, it'll automatically insert all the variables that you pass it in the order that you're giving it. So if I don't have parentheses, if I don't have variable right side, and credit numbers are held on the left side of the column, right, if you ever take accounting. With these formatting statements, you can easily specify how far over to push each item or where the starting point should be, and it makes it look a lot cleaner when you actually have the code output. And these are a couple examples that are basically the same as the ones we just showed, but they're here for you if you want to go back and check it out. Next slide. Now going into the examples really quick. So here first, we'll dive more into strings later, by the way, but here's a quick example of the 3 different types of strings or quotes you can use for strings. So there's single, double, and triple quotes. Single and double quotes are treated almost identically in Python. So for the most part, they're interchangeable, but when it comes to like code that looks clean and stuff, use them in different situations. Lastly, we have triple quotes, and these allow you to make multi-line comments and basically type longer strings of code into Python without it complaining because of all the white space it's easy. Next slide. Okay, here's a simple example of getting some input and converting it into floats. We have a constant for the comparison of miles to kilometers. We take an input and immediately convert it into a float that gets stored in miles. And then we take that mile value and then compute a new value for kilometers based off I don't know, got to multiply by the conversion number, and then you get an output that's printed by length in kilometers, whatever output whatever input you give it, is the output. Next slide. Okay. Here's exactly the same example. It takes an input and immediately converts it into a float for cost, and then for number, it takes another input and converts it into an integer instead, multiplies them together, and that result actually is a float, or I think it's a float in Python because the decimal one brings in some decimal values to the whole overall number. So then final print statement, very simple, prints them in the order that you place it in the print function, right?
Okay.
All right, moving on to section.
All right, so section 2 talks about functions and libraries. Let's go into some detail about what they are and some of their use cases. Next one, next slide. Okay, so this is a cheat sheet that you can use to follow along. It's some helpful resources. One thing to note, we are going to post all of these links for you afterwards, so you can visit them at your own convenience. Okay, so what is a function? Functions are basically a logical block that allow you to reuse code in multiple parts of your file. So let's take me as an example, and I'm walking. You don't want to write everything I'm doing when I'm walking every time I'm walking. It's better to have just one walk function and just reuse that same code so you don't have just some giant 1,000,000-line file. So you can just reuse the same function in multiple situations. So every function has 3 structures in it. The first is the declaration. You have to use the def keyword, and then followed by the function name, parentheses, and then you have an option of passing in parameters or not. The naming rules for a function name are the same as a variable. You can't start with a number, special character, etc. Basically, whatever rules for naming a variable are the same for naming a function, and same goes for their parameters since they are just variables. Parameters are just variables you pass into a function, so it's like a known value. So you don't have to calculate it or determine it inside the body. The second part of a function is the body of the function. This is where the work is done or some useful thing is computed or done. And then the last thing is the return. So every function must return something at the end. If you don't have a return statement, it'll return none. If you just have a return with nothing, it'll return none. So they're basically the same thing, but every single function returns something at the end. And you call a function by just specifying its name, passing in the parameters. There's 2 main rules to remember when it comes towards function calling. The first is that you have to make sure that the number of parameters that you pass into the function are the same as what you define the function with. So if you define a function with 2 parameters, you have to pass in 2. You can't pass in 1. The next one is to always add a return statement inside of your function. This is just good practice to allow people to easily read your code to understand that this is the end of the function. Because if you don't add it, it's just going to assume you return none. But to somebody reading, they might be a little bit lost and confused. Next slide. Okay, so now let's move on to some basic examples of functions. And this, again, comes straight from your assignments. Next slide. Okay, so this first example basically takes in one parameter. You pass in that number, square footage, and then the body of it, for this example, doesn't really matter because it's just some useful work is done. But one thing to note is it's returning one value at the end. And then as you can see, when we're calling it, we always assign it to a variable. Since we're returning a number, we should assign that number to a variable when we call it. And we have to pass in one parameter just like the function stated. So the feet to acre is going to have an error if you don't pass anything in. Okay, so this is another example, but this one's a bit more complex as it takes in more than one function. The body of it computes some value, area, and time, but again, we only return one value. And when we call it, we have to assign it to a single variable. So here, because it's returning a value, we assign it to another variable, time, and then we have to pass in width, length, and height, or speed, sorry. And this one thing to note about Python is that it allows you to return more than one value, and it doesn't place any restrictions on the type of value you return. So you can have a function that returns an int, a float, a string, all together. But it's really, really, really bad practice if you do that, and most other programming languages don't allow you. So good practice is to return one data type at the end. And don't get into the habit of returning more than one value, because again, other programming languages don't allow you to do that. And if you want to, pass it into an array. But let's just move on with Python and the syntax it requires in order to return more than one value. Since this one is returning 3 values, we have to assign it to 3 variables when we call it. We have to pass in the one parameter just like the function stated, but we also have to define 3 variables. So if we just have year and month equals date extract, that's going to be an error since we're missing day. We have to have the same number of variables in the return statement as what was in. We have to have the same number of variables in the calling as in the return statement. So this next example takes in more than one value again and returns more than one value, the numerator, denominator, and the product. So again, one thing to note, when we called it, we passed in 4 parameters as it stated. Go back. Yeah, go back. We passed in 4 parameters as what was stated in the function, and we assigned it to 3 variables per the return statement. But one thing to note is the name of the parameters and the return statement doesn't have to match what you assign it or what you pass in. So here, num1 and n1 are basically the same thing because parameters are local variables inside of that function. They only exist within the function. You don't have to follow that same naming scheme outside of that function. You can pass in whatever you want in terms of name, provided that the value is still the same. Next one. So this next example takes in no parameters at all, and when we call it, we don't assign it to a value because it returns none. So as you can see here, we just have an empty return, so that means it returns none. So it can't be assigned to a single variable. We can just assign it to so we can just call it. So this function, when you just have an empty calling, it'll run automatically when the interpreter comes to it. Because the way Python works is that it reads sequentially. Once it gets to that calling function, it'll run it. And because here it's returning nothing, you don't have to assign it to a variable. And one thing to note, all of the variables defined inside of that function math quiz are local variables and cannot be called, or you can't get the value of them outside of that function. If you want to do that, you have to create a global variable, which is just basically indented outside of the function. And last thing to note, we don't have an empty return. We just always put that return keyword. Don't just leave it there. Okay, so libraries and modules. So when you have a different file, you don't want to basically have to copy a function into every single file you want to use it in. You want to have a file and you just import it to save in a lot of the code, so you don't have to. So you don't have a giant file. So what you can do is you can have a library or modules, and you can think of these module, package, library, and frameworks as varying levels of abstraction. So you can just think of them as a container inside of a container inside of a container. A module is just a file containing libraries and global variables. A package is just a collection of modules. But one thing to note about packages is that you have to have the init.py file. That just allows the interpreter to understand what it is. And a library is just a collection of packages. A framework is just a collection of libraries. So as you can see, each one is just a box bigger than the last. So if you want to use a module inside of a particular file, you have to follow a very particular syntax. So here, there's two ways to do it. You can have from module import that function. So you just say from that module, import whatever function you want. And the other way of syntax is import the function in the module. They basically do the same thing, just different syntax to do the same thing in the end. All right, moving on to section number 3.
All right. Section number 3, how are we doing? Is everyone still awake? Are we good? Okay. Awesome. We're going to be moving to if statements and decisions. All right. Everyone made a decision to come here tonight, and we appreciate it. All right. So this is your cheat sheet. It's W3 Schools. We are not W3 Schools, but we do recommend their stuff. Moving on. All right. If statements. So hopefully by now everyone's familiar with if statements. Sorry, this is getting really hot. All right, so hopefully everyone's familiar with if statements. We're going to go over it again. So you have your basic operators, right? We have an equals, not equals, less than or equal to, and then greater than and greater than or equal to, blah, blah, blah. So hopefully we're all familiar with that. If you're not, they're there and practice. And we have a couple of special keywords. We have and or. I know I use them to conjugate each other, but your and does what? The left side and the right side of your statement needs to be true for your if statement to execute. And just like in English, you have or as well, and that's where either side, left or right, needs to be true in order for your statement to run. So let's move to the next slide. We have some examples. First example, this is a long one, and this is really showing you the else if statement known in Python as elif. So we have our first day number equals 1, our day is Monday. But if our day is not 1, it'll go to the next statement using the elif operator to say, well, is it 2? And then so on, 3, 4, 5, 6. So you could use these to do process of elimination, right? So we know that if our first one over here, number 1, does not run, it's false, then it will jump down to the second elif statement, number 2. And then if that's false, it'll jump down to the elif, and you go so on and so forth till we fall all the way at the bottom with our else statement with day equals error, because they did not input a correct number. Next slide, thank you. Now here we're doing the same thing, now using some other operators. We're using the greater than or equal to 300. And you can see at the top, at our comment, we're doing, good is 0 to 50, and then we have moderate, 51 to 100. And we're using the same principle here with process of elimination. So we know that if it's greater than 300, or let me use one of the ones in the middle here. If right in the middle where it's greater than or equal to 101, well, we know that if we start all the way at the top, because Python's going to run it like that, and then if it's greater than 300, well, we don't need to run any of the ones below it because we're greater than 300, so we have our answer. So it's just again like this process of elimination you can do with elif statements in Python. Then example 3, we're bringing in some of the and or operators here, like I was mentioning. So on our first statement, we have a comparison. We have 2 comparison inside parentheses. Now, it works similar to BEDMAS, if you're familiar with that. So our brackets always go first. So inside our brackets, we have 2 comparison. I'm looking at the first one on the left, on the first line. And we can see that we have 2 operations on the left. We have V1 greater than or equal to V2, and V2 greater than or equal to V3. Now, both of these need to be true in order for inside those parentheses to be true in Python. And then same goes for the right side with the other way. But we have an or operator in between. Now, the way Python's going to look at this is it's going to say, it's going to do the brackets first. So it's going to come down to either true or true, false or false, once you, break down those brackets and get those worked out. So that's kind of how you could use like that, your brackets to do sort of different combinations inside your if statements for more complicated statements. Next slide, please. And this looks like it's a little bit more of the same here. So we can move past this one. And yeah, so this one, we're getting a little bit more complicated using modulus, or modulo, I think it's what's called, the percent symbol. It's pretty much saying if you divide it by that number, is there a remainder? So if it equals 0, it means you do not have a remainder. And if it equals 1, you do have a remainder after using that operator. So this is just more of the same. Then we have section 4, for and while loops.
Okay.
Hopefully everyone's following along, coding on their own. Hopefully you have all those cheat sheets open on W3 Schools. We will have an intermission in the middle for everyone to take a break and, grab some coffee and stuff. So if you're falling asleep, don't worry.
Okay, so now we're moving on to the section that personally gave me the most trouble. I did not understand loops for like 2 years. So hopefully I'll give you some tips and explain it in a way that I wish I was taught when I was learning them. So let's move on to what are loops. A quick refresher about for loops. Let's just start with for loops, then we'll move on to while loops. For loops, a loop is just a block of code that tells a program to do an operation until a certain number of repetitions is reached or a condition is met. So basically, a for loop runs for a fixed interval of time, or fixed interval. So if you have a specific number, so run this 10 times, that's when you'd use a for loop. It could be running 5 times or until the condition is no longer met. But the structure is very similar to an if statement. In general, with a while loop, a little bit different with a for loop. We'll move on there. So when should we use for loops? For loops basically allow you to know the number of repetitions that your code will run for. So when you have a problem and you have a fixed interval of time, or a fixed interval of repetitions that this thing should be running for, that's a really, really good indicator that this should be a for loop. Or you have all the items that you want to iterate over, so you already know what it is you want to. The most common example is usually an array. So if you already have an array, you have all of the values in it, and you want to iterate over each of them, so you already have a fixed length, which is the length of the array, and you just want to iterate through it. So in this particular problem, a for loop would be good. So now let's move on to some practical examples to explain what is how to use a for loop. Okay, so the first example, here we're just calculating a factorial. One thing to note, the way the for loop works, we have the for keyword, then we have a variable, which is basically the iterator, then the in. The in keyword, you don't have to put in range, but the in just allows you to iterate over a list. Range is just a function that creates a list of a fixed length. So I know a lot of people just use the for in range without thinking much about it, but all a for loop is iterating over a list. The range returns a list at the end, and the first parameter you pass in is the first value of that list, which is 2. And then the second parameter is the ending index, which always, it doesn't go to the end, it goes to 1 minus the end. So that's why we put num plus 1. If we want to go till num, if we just put num, we'll actually go to num minus 1. So here, we're just having an array that starts from 2 and goes till num, and then we just calculate the prime. So now let's move on to some more examples of for loops. So here range has an optional third parameter, which is the count, how big the stride should be. So here we're passing in 5. So on every iteration, the iterator variable is increased by 5. So you don't have to go in one at a time, but you can increase it whatever you want. You can pass in a positive value more than 1 if you want to go twice as fast or 5 times as fast. You can even pass in a negative value if you want to iterate backwards through an array. So another example I can think of at the top of my head is if you start with the end index and then you go till 0 or till -1, you have to pass in a negative value in the third parameter in order to iterate backwards. So one really fun thing, hopefully you guys don't have a question like this because I'd fail it, is drawing Ascii shapes. A really good way to understand this one, this is just going to draw you a hollow triangle, is we have that iterator variable and just multiplies this the number of spaces. So on every single iteration, we start with a hashtag, and on the same line, we multiply a number of spaces equal to the iteration that we want. So if we have a triangle, let's say that area 3, so like the inside of it goes 1, 2, 3, then we have a fixed length, which is 3, and then in every single iteration, we just increase the number of spaces by that count or that iterator value. Okay, next example. All right, so this one here, it has a good example in that you can have a stop value that can be calculated outside of just the range. You don't have to pass in a value, like a very solid value. You don't have to pass in 5 or 1. You can pass in variables as your increment, as your start, as your stop. You can calculate it and make it more dynamic, but it follows the same structure in that you have a fixed length, which is increment or stop, sorry, and then you have a start value. So the same logic would apply again. And now let's move on to while loops. The way I like to think of while loops is just repetitive if. That's it, without an else if. But basically, anything that you can think of to repeat multiple times, but you don't know exactly how long it's running for, that's a while loop. So while loop work on the premise that it will continue to loop while the condition is given is true. So while this is true, do this. Once the condition is false, then it will break outside. One thing to note when designing your algorithm or your loop is to always make sure at some point your condition will become false. If you do that, you're just going to have an infinite loop, which you can do that if you want. There's certain use cases, but you generally don't want to do it. So here, basically, for loop is when you know how long it should repeat for. While loop is when you have no clue. All right, let's move on. When to use, okay, that's just this, okay, ignore the mistake typo. So when should we use while loops? Again, when we don't know how long the thing should be running for and we have no clue. For loops are basically while loops. You can implement a for loop as a while loop if you just have a count and then the condition is that count is less than the end value. But just for loops are just a shorthand way of using while loops. You guys mentioned it, you can't use break inside of your for loop. So if you find yourself wanting to use break at some point in your while loop, or for loop, change it to a while loop because it just defeats the whole purpose of iterating over a fixed length. So when you don't know what that length should be, or at some point you have to break, that means the condition at some point will be false, so make it a while loop. Now let's move on to some practical examples. Oh boy. Okay, so let's just look at what's the most important. Here, the string, like string equals not exit, that's the condition. As long as the string variable isn't exit, we'll keep repeating this block of code forever. And as you can see, this takes in user input. So this is just a good way of formatting user input. At some point, the user has to enter exit in order to stop that while loop. If they don't, this thing will never run. It will never end, sorry. So when you want to do user input, use a while loop because there's no way you can foresee how long the user input will be through a for loop. You have to use a while loop because you don't know how long the thing will last for. Okay, so now here we can, just like if statements, we can have a Boolean statement inside of the while loop. So while prime is true, so I don't know if you guys know this or not, hopefully you guys do. If you just have a variable name by itself, that means is true. So while prime is true and I is less than stop, which I is less than stop basically is, that's how you would implement a for loop as a while loop. Just have it less than the condition and then you increment that value at some point. So, and then you just increment it here. So this while loop will terminate at some point because you did define stop to be a definite number. So even if no prime is encountered, at some point I will become greater than stop and the while loop will break. So this is a good design principle to keep in mind, is you should always have an idea of at some point this while loop will stop. And if it's not in your first condition, it has to be in your second condition. Like if this was prime or, this thing would run forever. Because or, as long as one of them is true, the whole thing is true. So this is really poor design if you have prime or I is less than stop, because you don't know, what if you never encounter a prime? Then the thing will always be true and you'll never exit out of this for loop, or this while loop, sorry. So just keep that in mind when you're thinking about it. This next example, again here, let's just look at the most important things, which is the while loop and the condition we have, which is owing is less than payment. If we look, owing is always increasing at some point. Like here, payment never increases, it never changes. Payment is a definite value, owing is a variable value which increments. At some point we know owing will be greater than payment. So this while loop will stop at some point. This is good design because you keep in mind what this thing should be. Or when it should end, sorry. Next example. Okay, we can nest loops inside of if statements. We can nest them inside of other loops. But this loop, it will run, like it won't run if the absolute number is 0. So you don't have to run a loop all the time. You can nest it inside of a conditional. You can nest it you can put it inside of a function, you can put it outside of a function. It's very flexible and that allows you to place it in multiple different situations. Again here, because num is decreasing, absolute number is decreasing, and this is just integer division by 10, at some point it will be 0. At some point, because it is decreasing, it will be 0, and we're gonna exit out of it. And thus this is a good example again, thinking about that design. Okay, so just some closing remarks about for loops and while loops is you should always remember if you have a definite interval, use a for loop. Also, you don't have to have over in range. You can have for I in an array because, as I said before, range turns whatever interval you give it into an array. And a while loop, if you don't know how long the thing should be running for, you use a while loop and make sure that your condition in your while loop at some point will be false. Okay, so I hope this was helpful and you don't hate loops the way I did.
All right, so that brings us into intermission, is that correct? So we're moving to intermission, so if anyone needs to get up and stretch, go get some refreshments and snacks. Yep. Or if you have any questions, we're here, so come and ask them. Yeah, if you're online, put in the chat. We're We have chat open. We're good streamers.
It's okay, we'll have Q&A.
Yeah.
Do you want me to help tag in with you, or are you fine on your own?
You good? Alright, now that you all had a chance to relax and get some nice refreshments and stuff, we're going to start back up on section 5, lists and strings. So, for those of you who were listening at the beginning, lists and strings are very similar in Python. Only difference between them is that a string is immutable in memory. That doesn't really matter that much because when you're actually coding, you can save over the variable that's saving some string with like an updated value of that string or even an entirely new like string in its place. So, yeah. We went over this earlier, but 3 ways to define a string: single and double quotes and triple quotes. Single and double quotes are pretty much the same in Python, but they have some different visual use cases. I don't really know exactly how to describe it. For different applications, maybe like defining a dictionary, you might want to use single quotes for the key and maybe double quotes for a value, something like that. They also allow you to, say you have to like type a page from a book or something, you have different single quotes, etc. You know, you can use the, well, if you already say use say you typed a word with an apostrophe in it, and you need to print that, then you can just use double quote around that whole string instead, and that'll print out properly, if you get my point. Now, triple quotes, that allows you to write multi-line, either comments or actual strings. All right, moving on to different methods you can use on a string. So in Python, there's a bunch of different functions and modules that come built in. You might have already experienced a lot of these, but there's different classes of these functions. So there's case methods that will convert your entire string to a certain case, so uppercase and lowercase. There's trim methods, so these methods strip white space from certain parts of the string. And then you got strip, which takes from the left and right side, and then left strip and right strip. I'm sure you guys can figure that one out. And then we got search methods. So if you want to find like a certain character or where a certain substring starts in another string, you can use the find function. And this works similarly to the index function, but the difference between the two is that if find doesn't find the substring or character that you're looking for, it returns -1. But index, on the other hand, that will give you a value error, I'm pretty sure. And that means that your code will stop unless you put it into a try catch statement, which you'll learn next year. And there's also a replace function. So if you want to replace the substring, you can use this. All right, first example. So this example will tell you all the factors that make up a number, and here's factors, or different whole numbers that can be divided into it. So, but this, I think this actually might be the wrong example. This is wrong. Anyway, let's stay there, stay there. here's the string examples. Alright, so let's go from this. So what this one is doing is adding spaces between different words in a sentence, pretty much. It's gonna go through a string that you provide in the input and then add spaces into it based off where it sees uppercase or based off where it sees uppercase letters start. Just basically separating it really easily. It uses a for loop to do it, so if it sees an upper, then it will add a space to that spot or something very close to that. But that's the essence of this question. Alright, so this function returns the longest ending between two strings. There's a function called ends with. There's a function called ends with, and it does the hard work of finding out whether a string ends with a substring. Very simple. And then this, so this while just pretty much loops through. And so first word, so this is how this function works. It gets the first word that you're trying to search in as an input, and the second word that you want to find to see if it has the same ending. And then it basically loops through all of the letters in the first string and checks something. Okay. Sorry. Bottom line is the ends with function. This one checks to see if there's a word chain in a list that if you pass it. All it does is checks whether the last letter of a word is the same as the next letter of the first letter of the next word. It's pretty self-explanatory. This function just loops through and checks to see if it's a word chain based off that parameter. Okay, we need to go back. I'm gonna quickly talk about lists really quick. We have it, perfect. Yeah, so lists store data in Python in a sequential fashion. And Python is a special language in the way that you can actually put multiple different data types into a list. And it won't complain, and you can process it the same way that you're intending, right? And you can check to see, say if you're in a loop, whether a certain data type is X or whatever, then you can process it a certain way, right? So the first item in every list has an index value of 0, and so on. And then the last value has an index of -1, or however many however many values are stored in it. So you can access the final value by selecting the list at that final. So you can access the final value by saying like index at -1, or you can put the total length of the index of the array into that index, into the list spot right there. So you can also do some what they call list comprehension. You can split and select certain subsegments of lists. Say you want to, let's say you want to get only if you say 3 different elements from a list you have. In this example right here, we have red, green, blue, and purple. But we only want to print red, green, and blue. So what we do is use what's called list slicing, and we basically tell it that we want to access everything from the first index, which is 0, to the second index, which is technically the third index, which has an index of 2. So basically it'll select all those and print it red, green, blue, and that order. Alright, now lists have some different, so lists have a few different functions that are built in. There's the insert function, there's also append. So append will add a value to the end of the list. There's an insert function where you can specify the index that you want to add something into. Then there's also a remove function, which is pop, and that will remove the last element of the list. And then finally, there is, you can loop through them. When it comes to looping through them, you can move through individual items without specifying a range. So, yeah. Python does this by turning the array into what's called an iterator. You don't really need to know that. You just need to know you can do for item and array and get each item. It's very simple. Okay. We're going to skip past this right now. Oh. Yeah. Yeah, sorry, I kind of tripped over myself, but lists are pretty simple enough if you do a little bit of practice with it. So, on to Robert's section.
Yes. Yes, files and 2D lists. In case, lists weren't difficult enough, we made them two-dimensional for you. So, yeah, let's get started here. So what are 2D lists? So a 2D list is essentially nested lists. So if we think about our usual list, you have a grouping of values that are like ordered next to each other. We've seen them before. Now imagine if you were to put a list inside a list. We're talking listception here. We're going 2 dream layers deep in lists. And we're going to call that 2D lists. So we're doing lists inside of lists. And so they're really useful when you have groups of related data that need to be stored together. So imagine this lecture room, right? You're sitting in a grid right now. Imagine that each row that you're sitting in is a list. And each number in that row is an item in that list. Now we know we have multiple rows stemming all the way from the front to the back of the lecture room. Each one is their own list, but we want to be able to store them all in one, variable known as a lecture room. So we nest the lists inside of each other. So we have one big list that is, our lecture room, and then we have each row as another list inside of this bigger list. So we end up with a 2-dimensional grid, essentially, if you were to think about it in your head. Now, it's not stored like this inside of, your computer in memory, but the way to visualize it is in a grid, like, the lecture room that you're sitting in. Next slide, please. So ways to use a 2D list. For example, say you have a group of coordinate pairs you need to store to use for something. So imagine your seat number, right, is a coordinate on a grid, and let's say this one right here is 0, 0. And then as I go, throughout a grid, like think of like your normal plain grid X and Y, you can make that out of a 2D list because your x-axis can act as your first value, and then the second value in the list can be, the y-axis. So the example below, we can see 3, 4, 5, 8, and then 7, 12. And notice how they are lists inside of a one larger list. Next slide, please. All right, so ways to use a list. So here's a little example. We have coordinates, and these coordinates look like they're the same from the last slide. And we have a nested loop. Now this is very important because we know to get through one list, you need one loop. You loop from the beginning to the end of the list, usually using a for loop. Now, what if we have lists inside of lists? Well, you're entering, 2 dimensions as we discussed. So you're going to need 2 dimensions of for loops. So those are good. Just like how your lists are nested, your for loops will also be nested. And here we have 2 iterators. We have our I and j iterator. So it's important to know the order of these, as your I will be iterating between each list. So imagine, let's come back to our lecture room example, we have our rows. What's going to tell me that this is row 0, this is row 1, so on for 2, 3, all the way to the back? That's going to be our I in this case. I know I'm not exactly following the example. I'm kind of just using it on my own. But let's just imagine that. And then our J is going to represent each seat in the list. So if we're at I's 0, I'm at row 0 here. And then I want to look at seat 0. So our J value is going to be 0. We're going to go here. When J value goes to 1, I'll be here. 2, here, so on and so forth. Now when that completes, it's going to fall out of that and then go back to our top loop. And it's going to iterate me to the next row. And then I'll go through this row. When that completes, so on and so forth, till we get to the end. So that's sort of how that works with our nested loops. So here's a quick little summary. Once you understand regular lists, nested lists aren't difficult to understand, as you may have just found from my explanation, if it was good enough. And one-dimensional lists aren't a solution for every scenario. So you'll find 2D or even more nested lists more suitable in some applications. You could also get into 3D lists. We're not going to cover that, don't worry. But all you need to worry about is 2D. And if you understand 1D lists, 2D lists will be a piece of cake. Do we have anything else after this? Example 1. Yeah. All right, let's move into files here. So files in Python, they're not too difficult. It's just mostly like a syntax thing you need to keep in mind. When it comes to Python and scripts, you'll find many situations where you need to know how to read files, search through files, write to files, update files, lastly, delete files. And Python makes this very easy. So let's go to the next slide. So files functions. So Python has built-in functions known as open close parentheses, to open a file. This returns a file object, also called a handle, as it's used to read or modify the file accordingly. Closing a file will free up the resources. This is very important, that you close the file, because your computer will keep it open forever until you completely kill the script. So yes, open and close, that's what this slide is talking about. Let's go to the next one. So example 1 on our left, we can see that we have a nested loop here. Sorry, this is proper. That was another 2D list one. Here we go. We have 3 main parameters that we feed an open function. We have R is for read, W is for write. I'm looking at the left-hand side of our slide, by the way. And A is for append. And when you run your open function, these mean different things. So we see our open function, f equals open random file.txt, R. What does R mean? R means we can read the file. R for read. It's a read only. We cannot write, we cannot append, we cannot alter this file. And so our dot read will just give us a big print of the whole file into our console. Now, if we want to move on to the next slide, we have f.write. So dot write will write to our file, but we need to open the file in a write mode. This is very important. As you see in our open function, our second parameter is W. This means we can write. And writing also allows you to read. So this is important. So opening it in write access also means you can read, not just write. And writing to the file using our dot write will overwrite everything in the file. Just keep that in mind. Everything will be gone as soon as we write. This is now in the file. If it had things in there, they're gone forever. Next slide. Any questions? I'm just going to add, since we don't have another one. A is for append. So let's say I wanted to add something to the end of the file instead of overwriting the whole thing. I still want to be able to read, write, but not lose what I have. That's what A does. We had R in our open function, and we had W. Now, another one is A, append. I think I mentioned it. We didn't show an example, I apologize. But that will append. So it'll keep what you have already in there, and it'll just add what you're writing, or what you're appending, it'd be dot append, to the end of that. So yeah, that kind of wraps us up. Anyone has any questions as we sped through probably the hardest part of the course in about 5 minutes.
If you don't want to ask questions out loud, which I hope you feel comfortable enough to do, you can text it into the Twitch chat.
Yes, we are monitoring the Twitch chat.
Yeah.
Do we have any questions from Twitch? Ground control to Major Tom. Do we have? I'm sorry. Amazing question. Thank you, Twitch. So it's, what does /n do in /n in your strings and your print statements? Now this is a special character, and what it does is it simply pushes everything after it to a new line. It's known as it's a new line. What do you call it? It's a character, or yeah, new line character. There's different ones. There's the same thing like /t. That'll be a tab, so it'll put like 4 spaces next to it. It's just a way of creating a new line, essentially. So you want to create a new line without actually, making a new line, because you press enter in your IDE, it's just going to lose. It's just going to screw up everything. So if you want to put a new line, you use the /n.
Yeah, it saves you from having to do like extra parentheses. Trying to separate them, just use /n.
All right, cool. Hey guys, what's up? I got another question from the Twitch chat. Difference between in and in range for loops. When to use which?
Yeah, about that. The in and in range, it's the same thing. The in keyword functions the exact same way. It doesn't change. Range returns back an array. Well, it returns something like, it's an array within the range that you specify. The for in, and you put in the array, the I actually is the individual index or the individual entry inside that list. So when you have let's say I have an array of 5 chairs, every I or every variable, that is a chair. But in range is the index of that chair. So if I is 0, then the index of it is 0. But if it's just in, it actually gets the whole value of it.
Just the main difference between the two is that if you're trying to get a series of numbers or maybe loop through a series of numbers, you have an array, that's where the range function comes to play. But like I already said, you can actually loop through items individually just by saying in. It makes your life a lot easier if you already have an array. All right, any other questions, Nausha?
Thank you. Somebody asked, link to the YouTube channel. All the links for everything we're talking about will be available later. You'll be able to find stuff on Discord, and our YouTube channel should be linked in our link tree, as well as everything else as well. So, is there anything below the stream? Yeah. Oh, we do not have. Oh, we do. We have our website, our Instagram, our Discord, and our link tree. So if you do want to follow us on everything that we have, including our Twitch and YouTube, it's on our link tree, which is underneath the stream. And then last question for you is, what's the hardest part of the exam?
Before you answer that, while you're scrolling down, follow the Twitch channel. Thank you.
Okay, I think it's a question we can actually get multiple inputs.
Exactly.
Because every single one of us here has taken this course. So, anybody want to take off first? Safe, I know you had some.
Yeah.
Stuff on top
Okay, yeah. I had a couple of tips I wanted to give you guys with regards to the final exam. Nothing in particular is the hardest part, quote unquote. The thing I struggled most in the exam for me was just the definitions or some syntax, some obscure syntax that they put out at me. I remember the set. They asked a bunch of questions about the syntax of that, and I messed it up completely. I personally didn't have any trouble with the coding questions, but everybody's different. The way I would study if I could go back in time for this course, and actually any course in the future, is understand what was the structure of the midterm. From what I remember, the midterm had a lot of questions from your assignments. So go back to your assignments, dissect. Don't just look at the code and the solutions, but to actually understand why that solution worked under the conditions that were given, because they can ask variations of those questions, but they're along the same level of difficulty. So if you understand why it works, then you can recreate it no matter what they give you. Another thing, in the actual exam, read the question carefully and understand what it's asking. For me, like the most recent example I can think of was 312, CP 312. They asked us a question at the end, and there was one little detail I missed, and I wrote the entire solution note, and the guy gave me a 0 on the whole question. Yeah, it was 8 marks out of 40, so it was like 20% of the exam gone right there. So just understand the question, read very carefully what it is they're asking. Even if you can't get the answer at the end, you can't figure out the coding question, but if you have the required parameters, the required return statement, the if statements, everything else, and you just don't have the final answer, you can at least get some part marks.
That's
So,
a very good point.
exactly, yeah.
Okay, so anything you do in school, make sure you try and at least, if you don't think you have the answer, fill in something, okay? Because they'll give you part marks, especially in math and CS courses, because they know you kind of have a sense of the right direction to head in. You with me? So personally, what I remember from the final exam was figure out what's wrong with this kind of questions, kind of marks, okay? I'm not gonna lie. For me, that was because you think that oh, if you look through it well enough, you're gonna find an error, or it maybe it's just a really hard error to find. But then you're gonna hit some of them that you're gonna be like, whoever wrote this, did you even know where you were putting the error? Like, I don't know if you get what I mean, but you'll probably see that. Similar to what Steve said, the assignment questions, I remember a few of them showing up on the exam. My best advice is go through the questions that you think go through a good mix. In fact, I wouldn't say all, but no one has that much time. Go through some of the more difficult ones, and then some of the more basic ones, because combination of both will be used in it. You with me?
Yeah.
Rob, anything else?
Yeah, so I'm sure everyone here in any course has, ran into a question that's really difficult, and you're like, that's not going to be on the exam. That's way too difficult. It'll be on the exam. It will be on the exam.
Rule of thumb for life.
Yes, most likely.
Who
If you
knows?
think it's difficult, this is how you figure it out. This is how you figure it out. If you have a question for Twitch chat. Oh, sorry.
The question was, will the triangle Ascii question show up on the exam? The one where you have to use
Yes, the very difficult one
print.
that even we didn't want to do, will most likely be on your exam. Like, from experience, if you ever run into a question that's too difficult, it's going to take me too much time to figure this out, and I don't want to do it, it will be on your exam. I'm telling you that as a fact. For any course, that goes for anything.
Even goes for job interviews.
Yes,
Have
yeah.
things that they might show a question, or they hint you, they are giving it to you almost
Yes.
80% of the time.
100%.
Let me actually ask the rest of our panel really quick, who haven't said anything. Do you guys have any advice you give?
I do.
Okay.
You're not coding in an IDE on the exam.
Oh.
With me, I
Yeah,
run.
No coding assistance. There's nothing
Yeah.
like VS Code. No code formatting. You can't even tab because you're in the binary space like input box.
Even when you enter, it goes down 2 lines.
Tab, it'll bring to the button outside of it.
Yeah.
So I think I will keep complaining to the prof at the end. I was like, it's not fair, man. Like, you know how much time I spent pressing 4 spaces to make a code look good?
And then just read and make sure you didn't miss any little things, because
Yeah.
it won't tell you like it does in Eclipse.
D-boy, what about you?
I practiced in like a notepad, text edit, stuff like that. Just make sure you're comfortable not having an IDE. I practiced with notepad, text edit. Just make sure you're comfortable not using an IDE, but that's something small. Oh,
I have something quick to say too, and then I'll move on to the next question. Obviously, it's a bit too late because it's the exam's in 2 days now, right? But
Quick before you go on.
yeah.
What day is your exam, guys?
you guys.
Oh, you guys have bear time. Okay. So basically, if you can, rather than memorizing different questions, which works for a lot of people, I think for a lot of people, if you understand how the language works, like the basics of how everything works. You don't have to memorize anything, and then everything's pretty easy for you. Obviously, that's easier to say because you only have like 10 days to understand an entire programming language. But again, if you can understand it, which is like a completely different direction from memorizing everything, then everything that you'll get, any question ever, will be super simple to do. But that's what I recommend. The next question that we have is the midterm had questions exactly the same as lab or assignments. Will the exam be the same? Probably.
Maybe. We don't know. Prepare for the worst. That's the thing.
Yeah.
What if they put something you'd never seen before?
Yeah,
Maybe.
prepare for the lowest common denominator. Like always, just go for the hardest
Yeah.
questions. Another question that we have, I'm trying to rush through these because we have not a lot of time. For one CP104 session, they were allowed to use Python for their midterm, while another section did not have that option. Would all sections have the same rules, or would they be different again?
Can you repeat the question?
Yeah, for one CP104 review session, they were allowed to use Python for their midterm, while another section did not have that option. Would all sections have the same rules, or would they be different again? I can answer this if you want.
You can answer it, but what I'm guessing the question is saying is one part said to like code in Python, and the other part was asking for pseudo.
Somebody said after that.
Their hand raised.
Okay. I see. So the question is one class was one class was allowed to use an ID and the other wasn't. That's just for the Twitch chat. That was the question. It's going to be the same. It's fine. So midterms are like variable on the prof. The final exams are standardized across the department. So don't worry about your buddy being able to do open book exams, like someone said in the chat. Everyone will have the same pain, so don't worry. How many multiple questions are there? I'm assuming that says multiple choice.
I don't know.
I don't know. I don't remember.
I would say maybe 5 or 10. Like,
I remember it a lot. I don't know.
Yeah.
don't focus so much on multiple choice. If you do the rest of the code, you'll learn it. You'll learn how to figure out multiple choice. Rob, you have anything else?
Not really. If you have an outline, just refer to that. I don't know if you guys have an outline for your exam, but if you do, that'll tell you.
Yeah.
Yeah, so we're going to make these. You're talking about the cheat sheets.
Oh.
Right? We're going to make them available to you guys in a doc. In fact, we may.
Sorry.
Yeah, we'll put them on the GitHub, and we actually may end up sharing this presentation, but we have to still think about that.
Sorry, I thought you meant available on the final.
Sharing with you guys. Yeah, we're gonna fix it up by the way. So. All right. Any other questions before we start?
We'll email it. We'll email it out.
Okay. All right. Sounds good. All right. Thank you everybody for coming.
Yeah.
Thank you.
Guys.
Make sure you fill out the survey. If you,
Make sure
please,
you survey,
we do read it.
on your lawyer experience record.
And what?
Asking Mike real quick, Robert. Real quick question.
There's
Thanks for
one more
clapping,
question.
everybody. This is a pretty good question. Somebody said, if you haven't done anything for this course yet, comma, how should we prepare? And then someone said, good question.
The first answer to that is, I mean,
Go over the assignments. Do the assignments.
you're here for a reason. So this is like your refresher on how to prepare. But if you haven't done anything at all for the course, go watch some crash course videos on
Yes.
YouTube. Okay? That's the best advice I can give you.
And while you're there, check out our giveaway on Instagram. We have a giveaway going on. $150.
So
Wow.
3 $50 gift cards. So
It's crazy.
everybody wants one more
Yeah.
time. And thank you to our presenters and everybody else who got the things.
Thanks for coming out.
Good luck on the exam.
And good luck.
everybody.
Yeah. Are we running a stand-up comedy show now? Is this... You're going to cut my mic? Test, one.